Work Sharp just came out with our second folding knife. It's called the Madrone. We started with raw billet aluminum, USA sourced aluminum, and we machined that into the integral handle. It's a one-piece handle. And we're making most of it here in the United States. The handle's 100% made in the United States. Many of the components come in, we do the finish work, and we put that knife together, hand sharpened and everything, shipped out to you at a really good, fair price. Let me show you all the steps for how we turn this knife from that raw billet aluminum into something you're proud to carry every single day in your pocket. And we'll meet the team that does it.
Hey, this is Merlin Stewart at Work Sharp Manufacturing in White City, and I'm going to show you a little bit more about the Madrone and how we're making it. I'm a machinist. The game is, how do you get this awesome handle for the Madrone knife out of this block of aluminum? Well, first you got to hold on to it really tight. That requires vices and custom tooling and fixtures that can support the amount of forces that you're going to start putting into it. So there's a lot that goes into the initial planning phases of making a part. With the Madrone handle, as an example, we started just doing one at a time. And that was while we were kind of figuring out the different features and tools that we wanted to be using. Once we got how to do one of them at a time down pretty good, then we started producing more of them at a time. We're using this VF4 right now. Eventually, we're hoping to use a much larger machine that's going to produce a lot more. An example of some of those tools that I was talking about that we would need to use to install, like these slots in the back or this big slot for the blade inside. You can see over here, we need to set up libraries of all of these different cutting tools. That way we can simulate everything in our CAD and CAM systems really accurately, so that when it's time to go to the machine, we have consistent, repeatable, accurate results. So some details about the cutting tools that we use for people that are not familiar with this stuff already. A key seat cutter like this is going to be used for installing these kinds of slots you can see on the Madrone handle. Sometimes we call these a woodruff key cutter. This is a custom form mill. This is a carbide custom ground cutter that we had this shape installed by another vendor for us to help us install this unique geometry for the Madrone handle. There's many, many different kinds of cutters that we use for many different tasks when it comes to machining a handle like this. Now, if we go to the computer, you can see a little bit of the details that go into the work that we do here. This is a new fixture that we recently implemented. You can see it's on this tombstone, which is this rotational tool that allows us to array more parts at a time. You can see all these squiggly lines are all different cutting tools and tool paths that are going on. Each one of these is a unique operation that requires a great deal of detail that goes into telling the robot over there, the cutting machine, exactly what to do, how fast it's going to spin the cutting tool, how quickly it's going to approach things, etc. We simulate everything in the computer here after we've designed all of these fixtures. We use SolidWorks first for the purpose of designing. Then we import things into Fusion, which is where we generate all of our CAM, or computer-aided manufacturing or machining. After we've designed and then programmed all of our toolpaths on the 3D models that we like, it outputs what we call G-code. We then send that G-code over to the machine where we can review it at the control. That's when we load everything up, get all of our tools set up that we've defined beforehand, make sure everything's measured really, really well, make sure things are held onto really, really well, and then we hit the go button and we start making parts. Then we're gonna measure and check out, what did we get out of the machine? We're gonna validate against our 3D models and against our engineering drawings that were given to us by our manufacturing engineering team. Then we're gonna hand it on to our quality department and allow them to go through and give us all of the very, very fine detailed information as feedback, so that we can further fine tune exactly what we've got, what we've created.
So I'm Dario. I'm the one running Madrron handles on this CNC machine. To get started, we take these aluminum bars and cut them to size. When it's cut, we load this aluminum bar to the CNC machine. First, we machine at the front of the handle, and this is what that looks like. Next, I put it on the second side on the machine to finish both sides of the handle. Once the handle finishes the machining, I check every handle in deep burr.
Okay, at this point, the handles are machined. They're looking good, but they're not done yet. We're gonna drive them across town to Ashland, Oregon, where our headquarters is, and they're gonna finish these up, get them coated, and get them built into full assembled knives. In order to do that, we need the blades. Right now, blades are coming in from overseas partners. They're cut, they're ground, and they're heat treated. But we're actually working on doing blades in-house ourselves. So we have a laser cutter that came in the other day that's gonna cut out the blade blanks. We have a grinder that's on its way from Germany that's gonna be able to do the grinding of those blades. And I've got a wall here that we're filling up with blade steel so that we're able to build every blade for these knives in-house. I'm super excited about that. Right now, let's go over to Ashland, let's check out what we're building and follow the rest of the process.
I'm Greg Duncan. I'm a quality engineer here at Work Sharp, and as soon as parts are machined in White City, they come here and I measure them. This machine is a coordinate measuring machine, and it measures parts compared to the model file, and we can see if it's in spec or out of spec. This is a touch probe CMM, and so essentially it'll go around and touch the part in different areas, and it'll calculate dimensions based on the touching and compare it to the model file, and it'll tell me if it's in spec or out of spec. If I'm inspecting a knife handle and it passes all dimensions, then obviously it'll go to the next step and it'll be Cerakoted and then built. If it's out of spec, we'll write a report and then we'll talk to White City and make sure that we can get things changed and get them back in spec.
Hi, this is Carl Edwards back at the Work Sharp Knife Department here at headquarters. We just got in a bunch of brand new aluminum Madrone handles. At this stage, I sandblast these handles. I stick them in 20 to 40 at a time. Takes me about 25-30 seconds a handle to evenly sandblast this handle, get rid of all the burrs, blemishes, scratches. When they're done, I take them out of the machine. They look like this, completely different. No scratches, no burrs, all even gray, and then we send them off to Cerakote.
Hi, my name is Nancy. I'm here in the Cerakote booth. We just received our handles from Carl from the sandblasting room, and then they go in the acetone bath for about 15 minutes. After those are done, we rack them up and we put them in the oven to gas off. And after they cool down, they'll be ready to Cerakote. Today we're going to be spraying blue titanium. Those take 2 coats for each handle. And after we're done Cerakoting those, we'll put them in the rack, wait for 15 minutes so they can flash off, throw them to cure, and then after they'll be ready for receiving and quality.
Hi, my name is Jose Luis Ascension. Before I sharpen the knives, I need to check the angle for the knife, make sure the angle is the right angle. I sharpen the Madrron clipboard knife for 20 degrees. For the first step, I use the 120 bell. The second step is sharpening it for the X5. And after that one is the leather for making the finish good. When I finish the whole process in here, I send to the CMC.
Hi, my name's Anthony. I just got these blades fresh out of the sharpening room. Right now we're gonna run this CNC machine. We're gonna add a notch to these blades so that they have the ability to turn into an automatic pocket knife. So we designed this fixture right here that's designed to hold 12 blades at a time. And the CNC program runs for a couple minutes. Then once it's done, we send them off to get lasered.
Hi, I'm Kaylee and I'm lasering some of these blades right now. I do the spine lasering and each side so it shows the material that it is and what knife it's going to go to.
My name's Josh. We are in the quality lab and I just received some handles and blades for our Madrones. So what we do when we're in here is we actually inspect for not only that they are built correctly and everything else, but that they're cosmetically good. So I actually will inspect all aspects, make sure there's no nodules, divots, anything like that in the handle itself. We check the pins to make sure there's no cosmetic issues as well as they're pressed properly. We also, of course, check the Cerakoting itself to make sure that it's actually got enough Cerakote and it's not going to cause rust issues or anything else. So in order to measure the Cerakote, we actually use our tool here. We take a reading to verify that is with our specs. So we go through every one, inspect each one by hand, kick out anything that's actually has any kind of cosmetic flaws, any damage, and then we separate them, keep track of what the issue is. So now we inspect the blades. First thing we're going to check is the bevel to make sure there are no waves or any kind of deformities, nicks or anything like that. If there are, or if I think there's an issue, I can actually put them here in my magnifier and measure the bevel to make sure that it is correct based on our standards. So with this, what we're doing is we're actually measuring the heel and the tip, and we're actually measuring to make sure that they're within range. So they're allowed 0.012 difference between the heel and the tip. So anything that looks off, I actually will physically measure it, so that way I can make sure that the numbers are right. Like in this case here, it is actually passing. So what we're testing here is to make sure the angle's properly set, and the fail point on these is 1 degree difference. So a 1920 would be passable, but a 1919 would fail.
Hey, this is Carl. We're back in the knife room again today at Work Sharp headquarters, where we are going to put together our new Madrron series. We have shown you all the different ways we build and make the parts, and now we're going to show you some assembly. All right, so we're here in the knife room today, and I'm just going to put together this Madrron for you really quick. We're going to stick the button in the hole, insert our blade, make it all nice and fancy, drop in one of our very high quality bearings. All right, give that a little lube. Give our bearing on our B side pivot here. Just gonna assemble it. Now we have our rubber O-ring right there. Just gonna drop that in there, get her nice and centered. Spin it around, keeping my fingers out of the danger zone, because we all know we put out some super sharp blades. Put that keyway, line it up, drop that in there. I'm gonna flip it over, again, keeping my fingers away from that sharp edge. And grab me a screw over here, Loctite, ready to go. Drop it in there. Cinch it up. Work the bearing in the lube a couple times. Now to tune our knife, really simple. Put it at a 90, push the button in, relieve some of the tension on that screw till it drops. Now we should have a knife. We got no side wiggle, no up and down, lots of drop. And that's how we make our Madrone.
Hi, it's Josh again from Quality, and we just got this batch of knives in from assembly. So after the knives are completed and they are put together, they come back to me for one final inspection. Mostly what we do is cosmetic and functionality. So anytime we get the new knives, we take a look and we're looking for cosmetic issues, scratches, blemishes, anything like that. Make sure the clip itself has no scratches, no rust or anything like that. Then of course we check the knife itself. We always check to make sure it's got a 90-degree drop. And then once it drops and that passes, we snap it, test to make sure that the button itself isn't too tight. And I also check to make sure there's no wiggle in the blade. And then once that passes, we check to make sure the blade itself is nice and centered. And then that's the completion of it. Then this gets returned to the knife room itself where they go ahead and package it and send it on its way.
This is Carl in our new packaging area. We had to make this area into our warehouse because we are so busy in the knife room, we just needed more room. And now we're at our final stage. After our knives have been quality checked, I'm gonna take them. We got our nice little Work Sharp box here. I'm gonna open it up. We're gonna take an auto pivot. We're gonna take your combo driver for putting in your auto. Little extra parts for you guys. And our beautiful Madrone. We're gonna take all this, we're gonna weigh it, make sure we got all the parts involved. We're gonna put our little barcode, makes it easier for us to ship them to you guys. And there's another 24 Madrones ready to go to you guys.
That's every step that Work Sharp takes to build the Madrone knife. Every person involved cares deeply about their part of the process and making sure that this is a knife that you can count on every single day. Beyond that, Work Sharp backs every knife with a lifetime guarantee, so you can carry this with confidence. This is just the beginning for Work Sharp and for Work Sharp knives. I'm sure parts of this process will change, they'll get better, we'll bring more in-house, or we'll find vendors who deliver high quality out of house. But right now, this is how your Work Sharp knife is made.